welcome to Transcend Matter. This podcast aims to explore the fascinating interplay of materials that not only redefine aesthetics but address pressing human and environmental challenges. Every episode is brought to you by me, Emma Wright, a material developer and researcher, to converse with material experts from either an academic, designer, or research background. We'll be diving into their practice, exploring cross-collaboration and their connection with materials. Hello listeners, and welcome back to Transcend Matter, the podcast where we explore the intersections of material innovation, design, and environmental impact. Today's episode features an inspiring guest, Chetna Prajaputhi. I first met Chetna during a talk last year and was immediately drawn to her fascinating PhD research, which sits at the cutting edge of sustainable dye innovation. She's exploring enzymes, specifically laccase enzymes, can be used as a low-packed alternative to conventional dye methods in the textile industry, especially for dyeing wool and nylon. So if you're unfamiliar with current dye practices, most of them rely on high temperatures, harsh chemicals, and toxic auxiliaries that create significant environmental and health hazards. Chetna's work challenges this norm by using enzymatic processes that require low energy, fewer chemicals, and produce less harmful waste. Woo! So she's also working on a diverse colour palette, demonstrating that enzyme-based dyeing can achieve rich, bold colours, not just the soft pastels we typically associate with natural dyes. Even more exciting, she's researching how enzymes can replace discharge printing, a common but chemically intensive bleaching process, with a biological alternative. Very exciting. So for anyone not from a science background, enzymes are a biological catalyst. Yes, what does that mean? They are essentially proteins that speed up chemical reactions without being consumed. They're highly efficient, reusable, and sensitive to conditions like temperature and pH, which makes them a dynamic tool for sustainable innovation. So in this episode, Chetna walks us through her journey, her discoveries, and the potential for enzymes to revolutionize textile processing. Whether you're from a design background, science, or somewhere in between, you're going to find this conversation both educational and energizing. Check out the episode notes for links to her published papers and LinkedIn profile. So without further ado, here's Chetna Prajaputhi. Thank you so much also sending all those papers to me a few months ago. They were really, really interesting read, and actually I've kind of dragged some notes in just to kind of like gently remind myself.
Yes.
You've been exploring this whole process since 2018 roughly?
No, before then.
Before then?
Yeah, before then.
2018. So, okay, yeah.
So just to give you sort of an insight. So I started my PhD back in 2012, which
wow,
like ages ago. So I that's when I embarked on my journey exploring enzymes. Prior to that, I mean, I'd done a little bit of chemistry and a bit of biology where enzymes popped up in lessons. But prior to that, I hadn't engaged or even really understood them well enough. So that's back in 2012 is when I started exploring enzymes within the lab with a team, and really exploring their design potential and their creative potential within textile design. So prior to that, I think I mentioned this. I think you also studied at the Royal College, right?
Yes, I did. Yes.
So I've trained in textile design prior to embarking. That's the fire alarm going off. I don't know whether you can hear that.
What we can do, is it a tester?
Yeah, probably.
Okay, let's wait for the weekly tester because I can cut it out then.
Okay.
Is it finished?
Yeah, it's
we
gone.
We can keep it in actually.
Yeah, we can do. This is real life. It really is. So what was I saying? So yeah, back in 2012, I started my PhD, and I saw this advert which was focused on exploring enzymes for textile design potential. Sounded interesting. It was local to where I live, and I'd just completed my master's at the Royal College and started teaching. And it looked attractive, so I thought I'd give it a go. And a friend encouraged me to apply also. So that's when I really started exploring enzymes and what we could do with them, and sort of embarked on this journey of exploring the application of enzymes for design.
This is really interesting because I didn't actually realize you came from such a design led background, which for
Yes.
me is like just sings. Oh, that's just one, just fascinating. Like especially that collaboration between design or that sort of
Mm,
morphing of design into science and maybe design led science platforms. But yeah, I'd love to know more. So basically, I went through all your papers, super interesting.
yeah.
I loved it. Some of the names I cannot pronounce for life of me. I think which is one of them? Let me get this up. Two
Okay.
five diamminobenzene sulfonic. I have definitely said that. I have definitely said that wrong.
So it's 2,5-diaminobenzene sulfonic acid. Yeah,
Amazing.
this is part of my journey, learning how to break things up,
Yeah.
like chemistry terms, and even like some of the enzymes that I'm using exploring there. So, for example, laccase, which we
Yeah.
use to polymerize various aromatic compounds, belongs to oxidoreductase, which is a group
Hmm.
of enzymes. So, just understanding how to pronounce various chemicals, also, and understanding molecular weights and moles and all of that. So, I embarked on this really steep learning curve when I started my PhD, having come from a design background, working with textile chemists who, there are discipline norms, understanding that language, and sort of
Mm.
being able to communicate with them as well.
Mm.
I think because they have a very different method to working and exploring, for example, enzymes, and it's very methodological. Where I think in design, we would go and play is what we
Yeah,
would
you
go
learn
and
through
do.
play.
Yeah,
Mm.
so we would go and experiment, and we wouldn't, it'd be quite ad hoc, and when you're in a lab, you'd before you'd even step into a lab, you would start an experimental design essentially. So what you're going to go in
Mm.
there, what you're going to do, plan the experiments, various parameters that you'll be using, and so on. So I was introduced to a completely different way of working. And I
Mm.
think that's transformed the way that I operate now, and the
Hmm.
type of research that I do. I think I'd still say that I'd sit on the fence. So I'd still like to think of myself as a designer, but I say I'm more of a trained designer, but more of a textile chemist. Yeah, somewhere in the
Yeah.
middle.
Hybrid designer.
Yes, yeah, definitely. I do sometimes get imposter syndrome as well, depending on what
Oh,
crowd
don't
I'm
we
in.
all? Don't we all?
Yes, yeah. So it's been an interesting journey, yeah,
Hmm.
so far.
And how has there been any particular tools or people who kind of really helped navigate that transition from design into a
Mm.
science space?
I'd say my PhD supervisors, who
Yeah.
I still work with. So Professor Jinshong Shen, who's based at De Montfort University, who is a textile chemist, is his background. And he's been exploring enzymes and wool proteins since his PhD back in the 1990s. And also Dr. Edward Smith, who's a research fellow based at De Montfort University, also. I think they've been pivotal to my journey
Mm-hmm.
in terms of just understanding chemistry, the basics, and enzymes and bio reactions, biotechnology, enzyme-based technology, and I've gone on to continue working with them since I completed my PhD. So we currently work. We've been working on this really exciting project actually, which has
Yeah.
stemmed out of the work that we've been doing over the last, since my PhD. So we've worked on a couple of funded projects. The one that we've just wrapped up at the end of the last month
Mm-hmm.
explored how we could use protease, which
Mm-hmm.
is an enzyme um, extracted from a bacteria, for example. And we've been exploring its potential to separate blends.
Mm-hmm.
So, wool blended materials.
Interesting.
So, in industry, we have lots of different types of wool blends that we use. So, for this particular project, we've been exploring how we can separate wool from other fiber components like flax, nylon, linen, hemp, and then hopefully put those materials back into use. Um,
Oh,
and then one of the amazing things that we've learned from this, which is related to maybe the dyeing stuff that I've been doing, is through the process that we have established, we are able to extract proteins, so wool proteins, with still the dichromophore attached, so it's not damaging the dichromophore, which creates the color on a textile, for example. And we've been able to um, extract that color and then reapply it to a virgin textile
oh
um,
wow.
using bio-based, enzyme-based technologies, which currently is not possible, and no one else
Mm,
is doing that. So we're the first team to provide a proof of concept that allows us to extract the protein with the dichromophore still attached and then reapply it onto virgin materials to color textiles, which is really exciting. So we've applied for further funding.
wow.
And we
Okay.
did actually show, I don't know whether you had the opportunity to visit Future Fabrics Expo last year in the
Yes.
summer.
Yes,
So
I
we
did. I
did
saw your, yeah.
showcase some of our results there, preliminary
Yeah.
results, which showed how we could apply various dyes back on. And we've also been able to print with these dyes.
Yeah.
Um, Also, so that sort of links. So my work is ever evolving. When we're in the lab, we're coming across new ways and new things that we're stumbling across that we hadn't
Mm,
previously thought of. So it's quite exciting because it wasn't part of our project proposal, but it's something that
yeah.
we stumbled across that we were able to achieve while we were extracting proteins. Um, because ideally, we were extracting these proteins to engineer, so cross these proteins. Well, I'm going to try not to be too scientific. We were trying
No.
to extract various different types of proteins that we could
Yeah.
graft back onto the surface of the wool, of a wool material, for example, um, to prevent it from shrinking.
Mm-hmm.
So at the
Yeah.
moment, we use a Herscott um, chlorine process. So it's a synthetic resin that we apply onto our wool fabrics to prevent it from shrinking when we're machine washing them. And
Mm-hmm.
we're interested in producing a technology that uses wool
Mm-hmm.
um, that is broken down essentially into smaller proteins and then grafted back on the top to prevent it from shrinking. So it's a really interesting chemistry. So we've been working on establishing that. So we've had some interesting results with that particular project also.
Mm-hmm.
Um, yeah, and then we're
This is
looking to dye that at the same time. Sorry.
no go. No, I'm loving this. Is super super exciting. I remember hearing about your work through Rebecca at Walmart about looking at reducing uh, reducing the shrinkage of wool,
Mm,
and I didn't realize about the color there, and also splitting composites, basically, or not composites, composition fabric together
yeah.
into like different streams. This is really super fascinating. So I think from the work I know so far,
Mm.
you kind of really focus on like laccase enzymes. Have I said that right?
Yes.
Laccase.
Yeah.
Yes,
Laccase. Yeah.
brilliant.
Yep.
As a like basically a sustainable, even I'm not a huge fan of that word, or an environmentally friendly method of dyeing wool and nylon. That's kind of been your focus
Mm.
previously, hasn't it?
It
And
has.
which kind of
Yes.
ultimately looking to sort of eliminate sort of synthetic dyes and like
Hmm.
all those chemical auxiliaries. Just for
Yeah.
anyone out there who's curious to know why we need enzymes in our dye systems and textiles.
Mm.
So far you've really explored different color palettes, is that correct, through like enzymes of catalyzed reactions? You kind of got like pinks, greens, blues.
Yes. Yeah.
Yeah,
A wider
amazing.
range.
Yeah,
So this particular laccase you find
yeah.
in various plants. And they what they do within the natural environment is polymerize. So
Mm-hmm.
they um, join monomers up, so different compounds together. Okay, but they also laccase is also capable of degrading compounds, so
Hmm.
breaking compounds up into smaller components also in nature. So it's really exciting. This group of enzymes, which is called laccase, which I mentioned previously, belongs to oxidoreductase, the group of
Yeah.
enzymes. They take what they do is that they're involved in redox reactions. So they move electrons around essentially.
Mhm.
Um, and the work that we have been exploring with laccase is taking aromatic compounds, so simple compounds that we find again in plants, that are out there in abundance. We have been using the chemical grades, lab grades of these
Mhm.
particular compounds. But what we're doing is taking these simple aromatic compounds that we find in nature, and we're joining them up. And while we're joining them up, we're exploring how we can extend the color range. So
Mhm.
previously, we build on, and we've been building on other research that exists out there. So we're not the only group to explore laccase for coloration, for
Okay.
textile coloration. There are other groups that have successfully also colored textiles using laccase. But what our originality and what our contribution to the area is that we have extended that color palette to what previously existed. Previous research
Amazing.
uh, produce colors like browns and oranges and
Hmm.
yellows. And to a designer, that's quite limiting. It's
Limited.
quite
Yeah.
earthy, very natural tones, which is, they are beautiful colors, but you and I know that in industry, especially if you want to, I mean, colors change. There's new trends that pop in, and there'll be a yellow or a blue, or you know so I think and also to be able to compete with the synthetic dyes that exist out there, where you can get
Hmm.
fluorescence and all sorts. We
Yeah.
were
Like a
really
solid,
interested in,
strong color.
yeah, to see whether we could extend those color profiles, and
Hmm.
we've managed to do that with various different aromatic compounds that we find there, that have
Hmm.
various different functional groups that we can um, utilize that
Hmm.
by and we've been exploring wool specifically because it's made up of various amino acids, so it's quite complex, and that allows us to absorb these dyes and colors that we're creating through reacting it using laccase, essentially, and graft
Hmm.
and bond, essentially, is what we believe, onto the fabric surface. So we've
Mm.
achieved really great, like good color fastness results. Light fastness is problematic at the moment, um, but wash fastness and rub fastness is relatively good. So this is,
Nice.
again, I mean,
Two out
part
of
of the,
three.
yeah. So part of the work that we do, we have generally on a research project, we have commercial projects as well that will sort
Yeah.
of guide the process. And I think we're
Yeah.
really keen. I think this is, again, I mean, for something to work commercially, there are various standards that need to be met as well. So we were testing, exploring that when we were
Yeah.
undertaking the work.
And going back to wool, wool in itself is a really interesting material because from personal experience, when I've dyed wool or any protein fiber with novel dye feedstocks, let's say, its color fastness has always just been fantastic, especially in comparison to like cellulose.
Mm.
And in your opinion, do you believe it's like the structure of the amino acids within that fiber protein structure that allows that? Is that kind of, or
Um,
has nylon and wool? 'Cause you've mainly tested those sort of two fibers so far, I believe.
yeah. So
Yeah.
for what we found is the dyes that we're creating,
Mm-hmm.
using the enzymes, so the enzyme catalyzed dyes, you can say, has greater affinity to wool, and
Mm-hmm.
nylon is like a simpler form of wool,
Mm-hmm.
because it consists of those various functional groups. So cellulose, so cotton, is very different. We are able to color cotton, but we find the fastness of it and the
Yeah.
range and the colors are limited as a result.
It's also more
Um,
pastely, isn't it?
yeah, so we would probably need to treat the cotton with something prior to enzyme coloration, but we found that wool was probably the best fiber for this particular process because
Mm.
of its molecular structure and the various groups that exist on there that allow us to um, react with those amino acids that are present
Yeah.
there. Yeah, without getting too sciencey.
Yeah, no, this is great. This is all good. And what I do at the beginning as well is kind of
Yes.
almost do a small intro to like what an enzyme is, because some people might actually not, unless you want to have a really good description of what an enzyme is, because some people might
Yeah.
not know who listen to this, especially
Yes.
designers.
Yeah, so enzymes are biocatalysts that exist within all living microorganisms. They exist within us, in soils, and so
Yeah,
they're everywhere in our
yeah, they're
gut.
really interesting. Yeah.
Yes. And some of the end, I mean, we've been working with, again, I'm not too sure whether you may need to cut this out, but we've been, depending, we work with various companies that manufacture enzymes. So
Hmm.
Genicor, Novozymes, who are Novi, I can't remember their name. They've
That's
recently
okay. You don't need to
rebranded
name. That's okay.
themselves.
That's all right.
So they've Noviosis, I think is what they're
Hmm.
called now. Sorry, I should know
That's okay.
this. They've just recently rebranded themselves. So we've been working with them, and they're really fascinating. So their work and their R&D has focused on and exploring different enzymes out there.
Hmm.
And so they're always searching for enzymes that may work at lower temperatures, for example.
Mm,
Um, so, going to colder regions and finding enzymes that can catalyze reactions at room temperature, 20 degrees and
yeah.
30. So this is what's really exciting, where you take an enzyme from an environment which can operate at sort of really low temperatures, and then bring it into the realm of textiles, where,
Yeah.
especially within textile dyeing, conventionally when we're dyeing wool, we're dyeing it at the boil, and we're dyeing it for a couple of hours. So the technology that we've been working on, you can dye the textile for, at 30 degrees, for example, for half an
Mm,
hour, and you're already starting to see coloration, which is really exciting. So it doesn't use as
yeah.
much energy, pressure, and enzymes. Don't get used up in this biological process. So
Mhm.
they can be recycled and reused continuously unless you denature them or deactivate them, essentially. So there's so many opportunities that they offer within the sector of textiles. So
Yeah.
I mean, again, I mean, for your listeners, this might be quite interesting. So if you look at the packaging, or the labels of your biological detergents, you'll
Mhm.
find protease, cellulases within these biological detergents. So, we're already accessing enzymes through the process, particular products that we're using. So they're really well established, within textiles. Even laccase, the enzyme that I've been using, have been used to decolorize denim.
Hmm.
So
Yeah.
remember, I
Or
was talking about
discharge.
breaking up.
Almost a little bit. Yeah.
Yeah, yeah. So it can be textile effluent, so
Yeah.
breaking up compounds there, but also they've been used to decolor denim, so breaking them up, and giving
Mm.
us those washed looks that we love on the high street.
And they've also used for softening bast fibers. So it's really stiff,
Hmm.
like hemp and nettle. They use quite a lot in that sort of fiber softening treatment.
They do, yeah,
Which is they're everywhere. Which is
yeah.
I love them. Which is why I like Chetna. I need you to come on.
Yeah. Yeah, they're everywhere,
Yes.
honestly, in textile. Yeah, I mean, they make our cheese, our bread, our wines, and
Yes. Yeah.
yeah, so they're really exciting, and generating fuels as well now, and they're used in pharmaceuticals, so they're everywhere, and forever expanding.
You've also explored different screen and roller printing techniques like
Mm,
discharge printing and devore, was that right?
yes,
With
yeah,
enzymes as well. So, for those of you who don't know, sort of traditional devore is when you use a paste that kind of eats away the cellulose fiber within a synthetic and cellulose blend. And you kind of get like a nice engraving technique, don't you?
mm,
And then within the pile of the fabric, the height of the fabric. And then discharge is basic bleaching. Essentially, you're taking away the color that's in that fabric.
mm,
So both of them are very strong chemicals, right? For byproducts after the process, environmental, and probably also for the workers, depending on the locations as well. So, how has your explorations worked within that space? I'm hearing like color. I'm hearing like
yes,
shrinkage of wool, helping with that,
mm.
and also like
Patterning
aesthetically, yeah, patterning.
is what we call it. It's again, this uses protease and laccase,
Yeah.
and again, it's this is how, so protease, what we did with that was, protease, just to give you a bit of history on protease,
Mm-hmm.
it's been
Please, yeah.
explored to reduce like the wool prickle by degrading
Oh.
the scales, of the wool fiber, for example. And it's also been explored to prevent wool shrinkage in the past. So there's a lot of work that exists with protease.
Mm.
But protease is problematic because once it can break through that sort of outer scale, that layer, that surface that you find on wool, it can easily degrade and attack that wool fiber and break it down. So
Mm.
it's really hard to control. So various researchers have immobilized it, so made it slightly larger, which stops it penetrating the core of the fiber and so on. But it hasn't been commercialized because it's problematic in that space. But you'll find it in your detergents, for example.
Mm.
So we thought, okay, this is quite interesting. We can break wool down. And so if we were able to localize the activity, so
Mm.
restrict, I should say, restrict enzyme access to various parts of a textile, we could potentially produce different textures
Mm-hmm.
or patterns through that. So part of my work explored various parameters to control that degradation. So how far that we can break the wool
Mm-hmm.
that exists within a fabric, for example. And so we were able to, using various resist methods. So, for example, shibore being
Mm-hmm.
a sort of a physical resist that you can apply, we were able to produce some really beautiful textile surface patterns just using
Mm.
traditional clamping and folding techniques. And what that did was it limited where the enzyme could access, or areas of the textile that the enzyme could access when it was being processed in a liquor bath that had the protease in there. So I hope this is. I'm just trying to
No,
visualize what
this,
we've been doing in the
yeah,
lab.
this, no, I
um,
completely understand, and I'll also pop
yeah.
links in the blurb as well for
Yes,
people to like,
that would be fantastic.
of
So
course.
what we were able to do is restrict the enzyme access, so it would break down wool in a blended material, for example, a wool polyester. It would
Mm.
eat away at the wool and then leave the polyester behind. And because the fabrics that we were using, um, only the wool component was dyed,
Yeah.
when the wool is degraded or removed, it would lighten that area essentially.
Mm.
So it would create
Yeah.
contrasting effects within the textile. Again, different textural sort of effects, piles, depending on the different materials that you were using and how they're constructed, and the accessibility of the enzyme
Yeah.
to the wool fiber essentially. Um, and this work then has evolved into how we can break down wool into smaller proteins and then maybe graft it back on to prevent it from shrinking.
Huh.
But also the
Okay.
dyes, yeah. So we were the color that I mean, so when we were breaking the wool down, we had colored fibers almost coming
Yeah.
away that
Yeah.
we could filter out and then um, explore for different applications. So it offers opportunities for new materials to be created out of those
Yeah.
wool proteins that we're
Mm-hmm.
extracting at different sizes, for example.
Mm-hmm.
So again, that's a really exciting opportunity because we've not published anything, but we're looking to publish something soon on this. But we can separate various different sizes of
Yeah.
wool particles, and if we can separate them, um, we can start creating some interesting materials and different that have different properties to them
Yeah.
also. And then
Almost
we've
like
been
hacking
thinking,
that wool for a performance value, essentially.
yes, exactly. So we're
Yeah.
thinking about how we can also then we've been using other enzymes like transglutaminase that
Mm-hmm.
is used in the meat industry as a glue, for
Yeah.
example. And we've been exploring how we can use that to create almost new materials to cross-link some of these
Curious.
walls and yeah, to create more. Yeah, so there's lots of I mean there's a lot of work that we've been doing that we can't really talk about
No,
in
it's
great
fine. No, no,
detail.
honestly, it's
So
okay.
it's
No, this is honestly, it's
yeah.
absolutely fine. Can I come
So
and join? This sounds like
yeah.
so much fun.
Yeah, sure. You're more than welcome to come and visit one of our labs, and yeah, we're more than and show you yeah around.
This sounds
Absolutely.
such like a fantastic space to be in right now, and I think it's really unassuming. I think a lot, especially a lot of designers, might not
Mm.
understand the applications of enzymes, even in like the general textile supply chain. So to
Yeah.
hear it being used in a very sort of biohacking, I'm going to use that as a very loose term there,
Mm.
space is really, really, really interesting. My
It's
brain's just going
exciting.
off. Like, can I
It's
come and
really, I
play?
think, yeah, it's really exciting actually. Yeah, because I think, you'll stumble across something and that might trigger
Hmm.
something, like an error, like for example, how the dye industry started was through obviously the search for penicillin, for example, and then this whole, a sector industry just blew up in the sort of 19th century. So
Mm.
yeah, I think when you're in the lab and you're working, there's always sort of new things that you'll stumble across that, and opportunities that you
Mm.
could tap into. Um,
And how's the industry taking your sort of findings so far? Because you
mm.
displayed at the Future Fabrics Expo last year, and so far I've just seen kind of like papers or yourself in like talks. Um, what sort of feedback, or have you had any feedback so
So
far?
we always have research partners. We're always looking for sort of
Amazing.
commercial insights and understanding, because we have um, we have various partners that we work with.
Mm.
So I think industry are always looking for something that they can get to market soon as.
Yeah.
And some of the research that we've been working on is fundamental research. So it's gonna take at least 10, 20 years, for it to hit market, to scale things up. We're working on lab scale.
Mm.
Scaling that up takes a lot of time, and when you're looking to scale up, uh, just lab scale 10 times, for example, when we're looking at
Mm.
ratios, enzymes, and
Yeah.
and things like that, it takes time, because obviously we don't quite know what's going to happen in that space. So I think they've been really positive. They're really interested, but it's not something that they can commercialize.
Yeah.
So I think there's a bit of a barrier. For me, I think we need more investment and support from the industry,
Okay. Yeah.
and UK sort of funding councils and sort of areas like that, to really make this work on a larger scale. I
Hmm.
think also it's quite complex chemistry as well, so I think
Yeah.
there's a lot that we still don't know in terms of the toxicity of what we're producing. Um, so there's a lot of work that needs to be done in that field. It's really exciting, but also at the same time, I think there's a lot of questions that remain unanswered, and we've
Mm.
applied for funding, to explore some of these questions, to understand some of the compounds that we're generating,
Hmm.
um, and and to understand whether they actually do offer circularity, for example,
Yeah.
to ensure that they're not carcinogenic, just because they're polymerized using, these really soft, cleaner technologies, but we don't want to be making a compound and putting it
Yeah.
out into the environment, which could be problematic to different species and ourselves as well. So I think there's still a lot of work that needs to be done, but it's quite exciting to be at this kind of stage where we've got a proof of concept, but now we need to start testing it. So I think the industry have been really supportive, but also I think, we'd like more sort of investment from them. I think to and I think joined up thinking.
Yeah.
Um, Also, yeah, I think
And do you find that the investment will come, or from maybe the conversations you've had, more investment will come when you have more of an MVP sort of, yeah,
yes,
showcase?
yeah, without a doubt. I
And
think
but then you need to get to the MVP, you need more cash, right? Yeah.
yes, and this is that yeah that stage where
It's super tricky.
it is, and I think, only more recently are we starting to see, various government
Hmm.
funding,
Yeah.
sort of, research calendar opening up and understanding that the complex landscape that textiles and fashion finds itself within. So there are very many more calls that you can apply for,
Yeah.
which, might be relevant to textiles and fashion that they'll fund, for example. So it, yeah, it's a tricky stage to get to that stage.
Yeah.
Yeah, so yeah.
It's just it's yeah, I can't think of a better word than tricky, actually, I'll be honest. I
Yeah.
remember at FFE last year, one of the big talks was where does this financial risk come from? Does it come from the
Mm,
big brands like Kering, H&M Group? Is it more like wrapped into the banks? Because even these small brands who really might want to use, okay, products that are a bit more market ready, those market ready products are still really expensive for a lot of brands.
they
So
are.
it's who takes that risk in
Mm,
innovation and scaling up. Um, yeah.
yeah. Who does? I mean, it's a
I
really difficult space to navigate because we want to make
yeah,
advances, we want to do the right thing, but we're just limited with funding. And yeah, and I think investment is needed in the area. And is it, like you say, the brands? Is it, various financial institutions that fund it? um, the
yeah,
work. I think there is, again, I don't know whether I mean, Calorie Fix, for example, you can edit this out, but they've, grown tremendously in the last couple of years. I think I've
yeah,
seen them evolve, and I think,
yeah,
where they were, what they're doing right now to their pilot plant, I believe in Portugal, it's really exciting to see that
yeah.
happen, um, and
I've
getting that
worked with
backing
them.
investment.
Yeah, I worked with them previously when I was at Volleback on a garment
Right,
dye
okay, yeah.
process, and we brought like a capsule collection to market with them.
Yes.
So that was a really interesting process to work with them, and then the
Mm,
accelerator in Portugal. Um, yeah, we
yeah.
it's almost like you need brands almost to take the risk on those small capsule collections just to kind of like, hey, we've tried this is kind of what we
Yes.
got. But even we didn't reach like a color fastness of 4 or 5. We're around the
No.
3 4 mark, but we kind of marketed it in a way that that was okay for now. Like, we're trying, this is what you
Mm,
got, take it or leave it. But ultimately it's still cool when people do buy into it, because customers, as long as you show the whole as long as you're transparent to a degree with like where you are in your chain when you bring
hmm.
out novel products with different fibers and dyes that might not be to a classic commercial standard, most customers will be okay with it, because usually they come to the brand for that reason. If people
Yes.
just want to buy products that do exactly the same thing for a certain price point, they never really go to these interesting brands. They just kind of stay on the
Mm,
same sort of archaic sort of trends, if that makes sense. Archaic
yeah.
trends, but yeah, the same brands basically. um but yeah, no, they are really, really, really good example, I think.
Mm.
Yeah,
I also feel that maybe as consumers we need to for me, I think
hmm,
educating the consumer is really important as well.
yeah,
But I think with synthetic dyes that we get them in a multitude of colors,
yeah,
fastness, and so on, and they've been engineered to, stay around attached to that fiber for so long. Yeah, and I think we need to, I think even brands, consumers need to embrace some of the natural colors that exist in fibers. And I think we're
yeah,
really obsessed, the industry is really obsessed with bleaching out and white, and I feel that we could, you know, make our textiles in a more simpler way, which is a little bit more poetic and
hmm,
using some of the colors that exist as well. And I think, again, I think there's opportunities there that could be
yeah,
explored. Yeah, that doesn't require the application of synthetic dyes, which are problematic, especially I
yeah,
think with some of the work that we've been doing is when we're looking to recycle or put materials back into use, it's like, how do you remove that dye
hmm.
that's covalently bonded onto a fiber?
Which
Um,
completely lit my mind up when you were talking about that. I didn't
yeah.
know if there's a better way to make it more accessible for someone, maybe
Mm,
designers, to explain how that works. I mean, that was beautifully like described. But yeah, maybe I think feel some designers still don't quite grasp like some of the ripple effects of the dye industry, the negative ripple effects. Absolutely.
oh, it's problematic. I think it's because we don't see it and we're not
Yes.
engaged with it.
Yes.
It's a problem we don't have to deal with. But
Totally.
it's, yeah, it's an industry that we really need to yeah, really kind of reconsider how we produce textiles when we're coloring textiles. I
Yeah.
think there's so many adverse effects, from water pollution to sort of health of workers and workforce and so on. I think we
Yeah.
just don't engage with it, and this is why I feel that there are alternatives alternative ways of coloring textiles or using inherent colors that already exist. And we need to embrace that also alongside. So I don't think it's, I think with some of the faces that we face in some of the challenges that we face in the sector, I think they are complex, and there's not just one answer that's going to answer, you know, all the challenges that we face. But I feel that they're going to be quite diverse, and some of that diversity is
Mm.
accepting, you know, natural pigments that exist, so in cottons and wools, and embracing that. And
Yeah, which are beautiful.
I've seen some of that on the high street where,
Yeah.
you know, particular brands are starting to work with natural colors that exist in wool, which is really quite exciting to see
Mm.
brands tapping into that, and not just, you know, dyeing their fabrics or bleaching them and whitening them and so
Yeah.
on. Yeah.
You're celebrating like the not the history, but yeah, the characterization, the characters of that
Mm.
fiber. And yeah, and I completely agree with you. It's how do you bring like a wider awareness to the consumers, and I personally still think it's very much a brand's role to
Do
navigate
you?
that. Yeah, to
Okay.
some extent, yeah, because they are still the ones picking, going through the sourcing, picking the fabrics, picking the
Mm.
fibers, contacting people like yourselves, like the innovators, and they're the ones weaving the story for consumers to buy,
Mm.
right? So that's your ultimate space. So they're the drivers, because if someone turns around and say, "Hey, I need X amount of different types of like regenerative types of cotton and
Mm.
I don't know what have you," um, it's the brands that are usually requesting the drive, because it's either coming from the consumers or it's
Mm.
yeah, the ripple effect of trends, conversations, and investment, I guess.
And this part of my role also as an educator is trying
Mm,
to get the next generation to understand that also,
yeah.
to make better choices, to be a better designer when they're out there, you know, talking to. I
Mm,
think it's really important. Yeah, but also, yeah, educating the consumer, I think is, yeah, I think is one part of the part of the larger picture for sure. I think we need
yeah.
to, yeah, get them on board.
So what's next for you then? So I feel like you do so many things,
uh,
which is
um,
wonderful.
I think what are we working on? So I've been working on I think I'm sort of heading towards waste management.
Okay.
Which is really, no, like kind of within tech, it's really strange because honestly, I think that's what I mean. My next kind of keywords are going to be waste management
That's fine.
expertise, which is like The Sopranos. um, I'm not even joking. So I think it's kind of evolved. So it was kind of exploring bio-based biotechnologies, essentially is where I started out, and I'm still in that sort of realm of exploring enzymes for coloration, for as design tools, as creative design tools. And we've obviously been exploring separating fibers now, and I think it's more about material flows is what. So we've
Mm.
applied for funding, which is again, how much do I tell you? In terms of, yeah, I just
I
because I
mean,
need
you
to
don't.
be quite
Yeah,
careful that I don't let too much out.
that's okay.
Uh,
So
so
even
I'm
if you
just
just
gonna.
say apply for funding for a very
Mm,
particular open-ended project, like yeah,
yeah. So I
see what's.
think so. At I mean, the next stage of what we're doing is we're exploring how we can put those fibers, for example, that we've extracted and components that
Yeah,
we've extracted, how we can generate new materials from these components. So it might be
yeah,
wool, it could be flax, it could be hemp,
yeah,
and what potentially these materials could offer um, particular brands or yeah, sorry, yeah, I need to be careful because I think some of
that's
the
okay.
flax, for example, flax that we're extracting is much more finer
Yeah,
um, than the flax that you would typically find in your
yeah,
woven textiles, for example. So we're exploring how these fibers can be put back into use, and it's not as simple basically. So when
mm,
we're dismantling textile fabrics, essentially, we
yeah,
may be shortening the fiber length,
yeah,
which can be
yeah,
problematic, and as a result, we may not be able to spin that back into a yarn
yeah,
um, because we don't have the capabilities.
yeah.
of spinning very short fibers. So it
Yeah, and
opens
it
up
snaps a lot,
different
doesn't it?
challenges, but it could,
Mm.
yeah, it could be quite exciting because you might be able to manufacture these short fibers in non-wovens, for example,
Yeah,
again. So it really depends. So we're exploring how we can put these extracted fibers um, back into use. That's an area that we're
huh.
exploring, yeah, to
Very
create new
interesting.
materials. Yeah.
Yeah, there's some mills I've worked with previously who've really accelerated their R&D in that scope for
Mm,
their mostly for like wool over and cashmere over like the last 10 years.
mm.
Yeah, and also for hand feel as well. When it's short, it's quite dry, maybe a little bit prickly.
Yes,
So
exactly.
people want the word recycled next to it with the same quality, and obviously it's one. It doesn't quite work like that
No.
because of all the mechanical processes that need to go through. But yeah, really interesting is being explored outside of protein because I think there's some really beautiful recycled wool articles out there at the moment. But yes, I haven't really came across too many others outside the synthetic space.
Mm.
So I think that could be a really, really interesting
Yeah, you're going to see some
space for you.
flax and yeah, so I think
Oh,
we've got hemp, we've been able to all different components because we can break the wool down,
yeah,
we can extract the other components and it's quite exciting. There's also some work that I've been doing with another colleague which explores a chemical process to separate various textile fibers also,
yeah,
which is a different space. So it's using different chemistries to recycle and extract multi-textile waste, which again is really exciting. We haven't published anything yet with them. That's still being reviewed,
yeah.
but it's a really exciting space because it's using different technologies um, to extract textile fibers and then put them back into use as well. So I think I
Nice.
think waste management is where I'm heading at the moment. It's not
That's a
where
great
what I had
description.
planned.
But it's
No,
really
don't put
beautiful. No, don't put that in there.
don't put that in there. It won't do much for my image.
I think it's really interesting where you started from, like the RCA. You
Yes.
kind of saw this advertisement about enzymes and textiles, and now
Mm.
you're kind of like moving into this sort of like upcycling more like recycling space, isn't it?
Yeah,
Like chemical recycling.
space and materials
I think it's a
development and
yeah,
yeah.
sure. Yeah. So this is a really beautiful journey that you've laid out for us. And I think it's actually quite inspiring for people who might feel quite siloed, whether it's
Mm.
in chemistry, engineering, textile design, what have you, that actually I think there is definitely a space in the UK and obviously in other parts of the world as well, where people can sidestep a little bit and have their sort of skills needed in other spaces. Do you feel there needs to be more mm, focus on that, especially in educational spaces?
Yeah,
Or
absolutely. I feel like there needs, I mean, research councils, especially in the UK, have been fostering that thought of coming out of your
yeah,
discipline and working interdisciplinary or transdisciplinary sort of collaboration. So they're really supportive of that. So I think the landscape is changing now. I think we need to
mm,
come out of our silos, talk to one
yeah,
another, um,
here we are.
understand one another's jargon, and see how we can benefit from collaboration. So I think it's really important um, to work collectively. So yeah, we
Yeah,
need. I think our education system, I think is we are seeing a lot more interesting disciplines popping up that sort of combine maybe traditional sciences with design, and those various institutes I won't mention that do that really well
yeah,
in the UK and do take that risk and evolve curriculums and so on, where others are probably um, a bit more traditional in a sense where they're sort of still
yeah,
working in that
sure,
silo way. But I think industry really requires designers that understand some of these processes
yeah,
better, especially economics and chemistry and sort of testing and all. I think it's
yeah,
really important that um, we expose the next generation to different types of thinking and sort of working
yeah,
collaboratively with different disciplines that they wouldn't naturally work with, because there's a lot of crossover and it's just opening them up to that kind of thinking
yeah.
that exists out there. Yeah.
I completely agree. That's probably also one of the reasons I started my consultancy, was to really breed that and try and be the connector
Yeah.
and innovate between the two spaces, because there is definitely a requirement, albeit it's still quite a grey space, I think, for a lot of spaces. Yeah,
It is. I think I
it's
don't know whether
time.
it's I don't know what it is because I find
Mm,
the undergraduates that I work with, they
mm,
just want to make and they're not interested
yeah.
in that science as much.
Oh,
There are the odd
curious.
few, there
Yeah,
are
yeah,
the odd
yeah.
few, but I think I don't know whether our brains are just wired slightly differently. So
That's really interesting.
I
Yeah.
find that having
Huh.
worked with a younger, I don't know whether I think there are the odd few who are really happy to kind of explore and come out of the discipline
Yeah.
and try something new. But I don't know whether I don't know whether our brains are just tapped to do things.
Maybe.
Yeah.
Maybe. I don't work in education directly at the moment, probably a
Mm.
bit more indirectly through different projects, but I have always had a love of science when I was younger.
Yeah.
When I was doing my BA, the BScs didn't appeal to me then. It was just
Yes.
so, you'd go into a system, you'd come out a certain way, but everybody would be the same. And you'd be
Yeah.
like, oh, I'm too, well, not independent, I'm too like neurodivergent for that. I was just,
Yes.
yeah, I just, there was no personalities were allowed, let's say. But anyway, and that science has always really fed into my understanding of textiles and engineering,
Mm.
textile engineering for years and years, and I really allowed that to grow in RCA. But yeah, that's so interesting that actually maybe some people are just wired a certain way and they sing when you have this sort of STEAM space, science, technology,
Yes.
engineering, arts, media,
Yeah.
floating around. And actually, but it is still okay for people to maybe still want to be in their silos. So actually, yeah, being aware of both of those synergies. Yeah,
Mm.
I didn't think about that actually. Yeah, that's really interesting. Well, thank you so much for your time
My
today.
pleasure.
If would you like people to reach out to you? Maybe you
Y-
don't. If people
yeah, happy
just to hear
to.
about your work, is there a
Yes.
website space to learn about
So
everything?
I'm very my what do you call it?
Practice?
Oh, not practice. What's the word I'm
No.
looking for? My outward facing sort of
Yep.
profiles are very
Nice.
limited. I think people can reach out through obviously my university email address. I'm on LinkedIn,
Yep.
and that's pretty much it.
That's
I have
fine.
obviously a Google Scholar page, but yeah, generally I think if people are interested in contacting me, it would be via my
Yeah.
university email. Yeah, because I think it just keeps things a bit more focused for me and manageable.
Transcend Matter is a series-based podcast with monthly bonus episodes. We would love you to join our material community, so please do follow us. This will really help spread all the information we have here to a wider audience. We hope you have been inspired and will join us on the next show. This podcast was brought to you by Studio Osmo, bringing together a collection of minds and skills to accelerate future innovation within materials.